Hi everybody, welcome back once again to this channel. Thank you very much for joining me once again. Guys, if you're new to the channel, please make sure you've subscribed. Just turn on that notification bell so that you can be notified every time when I upload a new session. Okay, just on the comments, I saw this person has been bothering me saying, hey sir, please do question 4 from Free State. So yeah, this is your question 4 from the 2024 trial exam, Free State province. It's under analytical geometry. I didn't want to upload it because I know you guys are writing tomorrow, right? So that you don't get anxious, you just relax and just be revising whatever you need to revise before you write. But the person has really been bothering, so I thought, okay, let me just record it quickly, and hopefully this will be helpful as well. Okay, let's go into it. Okay, question 4. We are given a diagram with a circle with center M. That's the bigger circle, right? Center M, it's for the bigger circle. It's touching the x-axis at C and the y-axis at point B. And we have another second circle, the smaller one. The equation is given as well. We have these two circles are intersecting at A and at B. Can you see? So also the equation, we have a chord AB, which is that straight line, which is given by y equals to minus x plus 1. So 4.1, they want us to show that the circle centered at M, that is the bigger circle, has this equation. Okay, so how can I show that this bigger circle has that equation? I'm only given the equation of the smaller circle, guys. So I have to use the information given to solve, right? So basically, to get the equation of the bigger circle, we can deduce from the standard formula x minus a squared plus y minus b squared is equals to r squared. So the idea is that if I get the center, that is the point M, right, which is A and B for this case. If I get that center and also the radius, I can just expand that and show them that at the end it will be like that, right? But it's 5 marks, guys. Okay, so it means I need to know the center M there, right? Let's just call it XY, right? The coordinate of M. So, but I'm given this equation of the smaller circle. So I know that on the smaller circle, if I know its center here, right? The center, the coordinate of the center of the smaller circle, and also because that distance there will be the radius of that smaller circle, then I can actually go and use distance formula to get perhaps one of the coordinate of M, right? Either x coordinate or y coordinate. Okay, but what is key to also check here, guys, is that the y at B, remember B is the y-intercept, right, of that equation. So B would be like 0 and 1, because from this equation, you know, y-intercept is 1. So the point B there obviously to be 0 and 1. So it means that y at B, because of this vertical line there, maybe let me highlight it here, y at B is the same as y at M. So we have already found one coordinate of M, right? So it means M, it will be x and what? And 1. Because we are seeing that y at B, because we are saying y at B is the same as y at M, which is 1, right? Because it's the y-intercept of that equation. So because of the straight line there, so they have the same y value. So I already found the y coordinate of my center M. So I'm only left with finding x. So now to find x, you need to know the point there at the center of the smaller circle, because now here we have 1. So you can also know the radius and use distance formula to solve for x. Okay, so let's just go and explore that. So it means the first thing really we need to do is let's get the point, the center of the smaller circle. So the equation is x squared plus y squared plus x minus 3y plus 2 equals to 0. That is the equation of the smaller circle. We want to get the center, that is, you have to complete the square, okay, the center and the radius. So to complete the square, let me group these ones that looks the same like this and take 2 to the other side, would be negative 2. Okay, I go to the coefficient of x, right, which is 1. I multiply by 1 over 2 squared. This will just be 1 over 2 squared. Okay, that's the coefficient of x. Coefficient of y, it's negative 3. I say negative 3 times 1 over 2 squared. This will be negative 3 over 2 squared. Okay, so what do? I go and add these things there. Okay, the coefficient of x and the coefficient of y. So I'm going to say x squared plus x, the coefficient of x, 1 over 2 squared, it was 1 over 2 squared, right? I go to y, then this was the answer, it was minus 3 over 2 squared. This is equals to minus 2. What I added on the left to ensure that my equation is balanced must also be added on the right. So I'm going to add 1 over 2 squared and also minus 3 over 2 squared that I just introduced on the left. Okay. Now we can factorize, guys. It's very easy now. So for x, it will be x plus 1 over 2 squared. For y, it will be y minus 3 over 2 squared. Okay, then this one you just punch on the calculator. When you punch, it will give you half. Okay, so now your equation is in that standard format. So you can note that the center of the smaller circle there, it will be what? Remember, if it's positive, you change the sign, minus 1 over 2. This one is negative, you change the sign, it will be 3 over 2. So the center AB there is what? Minus 1 over 2 and 3 over 2. And it makes sense that x is negative because it's on the negative x. And y, it's positive 3 over 2 because it's on the positive what? Positive side of y. Okay, so in that format, 1 over 2 will be standing for what? For r squared, right? Inferring from the format, standard format of an equation of a circle, then you know that the radius will be the root of 1 over 2. Okay, so now after getting this, I know that radius is root of 1 over 2. I can use distance formula between the 2 points because I need the x at m, right? Using distance formula, I have the distance there, which is a root of 1 over 2. I have the point there. I'm looking for the x that side. Okay. So from the distance formula, the radius is the same as the root of x at m minus the x at the other circles thingy, which is minus 1 over 2. This is squared plus y at m, which is 1, right? We already deduced it's 1 because of that straight line there, and that y there, it's 1, right? Minus y at the other point is 3 over 2 squared. Okay, so the radius was root of 1 over 2. This is what? Root of x plus negative and negative plus 1 over 2 squared plus this side, it's 1 minus 3 over 2, which on the calculator will give me minus 1 over 2 squared. Okay, to cancel the square root, I can square both sides. I'll just have 1 over 2 is equals to x plus 1 over 2 squared plus minus 1 over 2 squared. Okay, then you can go and expand and finally solve for x, right? At the end, when you solve for x here, guys, because of time, I'm not going to expand and all that, but you're just going to go and expand and all that. When you expand, you realize that x will be equals to 1, right? So it means my point M, it's what? It's 1. Actually, x will be negative 1, sorry. You realize your x is negative 1 because it's on the negative side. So it's negative 1 and 1. That is the point M. Okay, so now after getting point M, I can now go and find and express it in that format that they want, right? Let me just delete for space. So rewriting x minus a squared plus y minus b, the equation of the bigger circle is equals to r squared, so that we show that it's the same as that. So I'm going to have x minus, so remember, if it's negative here, it will enter because negative, negative, positive 1, right? Squared plus y minus 1 squared, right? what is the radius of the bigger circle? So check here. Let me just erase, guys. It's messed up here. So the radius of the bigger circle is the distance from M, the center, to the circumference B, right? And we already know that x there is -1. So that distance to 0, obviously it's what? It's 1 unit. Okay, from 0 to 1 to -1, obviously it's 1 unit. So R will just be 1 squared. Okay, that's the radius. Then you can expand now. It's x squared plus 2x plus 1 plus y squared minus 2y plus 1 is equals to 1. Okay, then you can show them that indeed it's the same as that, x squared plus y squared plus 2x minus 2y, right? So 1y will cancel with another 1. I will be left with the 1 there. I mean 1, not 1y, right? I'm saying when you take 1 that side, it will be 1 minus 1. That side will be left with 0, right? So here I'm left with this 1 is equals to what? Is equals to 0. So then you have actually showed them indeed that the equation of the circle-centered M is like that. Okay, it was a bit of a tricky question, guys, but you just had to use your given information. You were given the equation of the smaller circle, so you got the center of the smaller circle, and then you also got the radius, right? Because you had to complete the square of the smaller circle to know the center. After getting the center, you use the distance formula to actually get the x coordinate, because the y coordinate was already there, because this is a straight horizontal line. It means y at B was the same as y at M, and y at B is the y-intercept of this line, which is 0 and 1. So 1 is also the y at M. So you are only left with x, which we had to use distance formula to get it. All right, I hope you find this helpful. Let's quickly go to 4.2 now. Okay, 4.2, it says determine the coordinates of the center and the radius of the circle which passes through B, M, and A, right? So we have to find the center of the circle and also its radius. This one that is passing through point B, M, and A. So it's the smaller circle, right? Find the center. And we had already found its center when we were trying to find to show that the equation of that is that in 4.1, right? Remember its center, it was what? We completed the square, right? I'm not going to repeat that process. So after completing the square using of that equation, we got the center as -1/2 and 3/2, right? That was the center. The radius, remember it was the root of what? Root of 1/2. Okay, so we can just quickly move to 4.3, which says calculate the coordinate of A. So if you check, A is the intersection of the straight line, which is y equals to minus x plus 1, and this circle. Okay, so that's the idea. 4.3, the two are intersecting. To get A is the point of intersection between the line y equals to minus x plus 1 and the circle, which is given by x squared plus y squared plus x minus 3y plus 2 is equals to 0. So what I can do is to show that the two equations are equal. Where there is y, you just go and replace it with what? Negative x plus 1. Okay, so I'll have x squared. Wherever there is y, I put a negative x plus 1 squared plus x minus 3. Wherever there is y, I put a negative x plus 1 squared plus 2 is equals to 0. Okay, then after that you can just simply go and expand those things and use, I think you can factorize or use quadratic equation. When you have expanded, then you solve for x, right? So when you solve for x, you'll find x equals to 0 or x is equals to negative 1, right? So obviously you know that in this case, sorry about that. You know that in this case, obviously A can be 0, right? So 0 to be for B there, where it was 0 and 1. So there x is negative 1 for at A. So to get to y, you go to the equation minus x plus 1, you substitute your x, which is negative 1, and you'll get 1 plus 1, which is 2. So your a will be negative 1 and 2. Okay, so that will be the coordinate of a. So it's the point of intersection. So you use the straight line and the equation of a circle. So you just come and substitute that straight line, which is y equals to minus x plus 1. Where there is y, you put that, you solve for x, and you check where which one will be the suitable value of x. Let's quickly go to 4.4 now. So 4.4, they are saying the straight line with the equation y equals to minus x plus k is the tangent to the circle with center M, right? So they are saying there's another equation which is minus x plus k, right, which is a tangent to the circle with center M, right? Perhaps let me just show any line here that could possibly be a tangent to a bigger circle. Okay, so obviously tangent touches at one point. So they are saying show that this equation now can be written like this. Okay, so to show them, you see that now the new equation has some k there and all that. So basically, where the two equations are touching, the tangent, which is y equals to minus x plus k, it's now intersecting with the bigger circle. So what I do is I just go and replace y on the bigger circle with minus x plus k, right? So the equation of the bigger circle is there. So it was 4.1, it was x squared plus y squared plus 2x minus 2y plus 1 equals to 0. So where there is y, I'm just going to substitute with that because the tangent intersects with the circle only at one point. So there's a point of intersection. So y is the same as minus x plus k squared plus 2x minus 2, where there is y minus x plus k plus 1 is equals to what? Is equals to 0. Then you can really just go and expand, right, and finally show them what they need to you to show there. So to expand this, so this will be x squared, right, and this minus kx, it will be minus 2kx, right, plus what? Plus k squared. When you expand that, and then you have plus 2x, then you remove by minus 2 there, you'll have like minus, it will be plus 2x, right, plus 2x and minus 2k, right, minus 2k plus 1 is equals to 0. Okay, so when you try to expand there, then you can group the like term. You have 2x squared here. Let's see if we have another like terms. Let's just put them together. Plus k squared minus 2kx minus 2k, right? These two will give us 4x plus 1 is equals to 0. Okay, so the rest, guys, is just for you to go and check what they did. So they tried to write it in the form of ax squared plus bx plus c, right? Where you see the coefficient of x, they take a common factor, then you have your constant, then you have your a. So our a is this one. So let's go to the ones that have x. So the ones that have x is those ones. So if you come and see 2x squared, the ones that have x, if you take x, you'll be left with minus 2k plus 4, right? Then the rest is just k squared, right? K squared minus 2k plus what? Plus 1. Okay, then you can now see that it's now written in the way they want. Okay, key question, it's 4.2. Let's conclude with it. Okay, 4.2, it says calculate the numerical value of values of k. Okay, now find the values of k. So from the previous, we were able to express it like this, right? You know, this is a quadratic equation because we can see x squared, we can see the coefficient of x, we can see a constant, right? So you have your a there, which is 2, coefficient of x squared, b is the coefficient of x, which is 4 minus 2k, and c is the constant, which is k squared minus 2k plus 1. They are saying find the values of k. Okay, someone might be confused. How will we find the values of k? So guys, they told you that the equation there is a tangent, right? And if it's a tangent, it intersects the circle there, right? It means that the roots, the x values of this equation will be the same as the x values of the circle at that point. They have the same x values. That is, they have what? Equal roots. That's the key you have to use to answer this. Okay, so because if they are intersecting, they have the same x value. It means that having the same x value means that the roots are equal at that point. Okay, it means that in other words, delta must be equals to what? 0. And you use this idea to solve the values of k. So delta must be equals to 0. So we know that delta is b squared minus 4ac. I just go and substitute my b is 4 minus 2k squared minus 4. My a is 2. My c is k squared minus 2k plus 1 is equals to what? Must be equals to 0. Okay, because the roots are equal. Okay, then using that, guys, you can quickly just go and find the values of k. All right. So I'm not going to go and expand and try to solve there. The key thing is for you to understand the concept, right? You can do that by yourself. At the end, you'll find that your values of k will be plus or minus root of 2. All right. I hope you find this helpful, guys. Don't forget to like, share, comment, and subscribe. And all the best, guys. All the best. You are well prepared for your paper 2. Just be calm. Just be at ease. And I wish you the best of luck. That's all from me. See you soon. Bye.